Hey math fans, in this video I'm going to go over properties of trapezoids and kites. This is section 6.6 in the textbook, so let's get started. The first thing I'll cover is how to define a trapezoid. A trapezoid has opposite bases, but only one pair of opposite bases. A parallelogram has two pairs of opposite bases. They're both quadrilaterals. So the trapezoid has one pair of opposite bases, and then the sides of it are called the legs, kind of like similar to that of the legs of a triangle, I guess. And you can have something called an isosceles trapezoid, and that's when the legs are congruent. Okay, but you can clearly see they're not parallel. And an isosceles trapezoid will have congruent legs, and then it'll have congruent base angles. These are called base angles since it's associated with this base right here, and these are also called base angles. It's associated with this base there. They're not necessarily congruent to the top and bottom ones, but what you do know is that since this is a quadrilateral, the sum of all the angles is 360 on the inside, and whether or not it's an isosceles trapezoid or not won't really affect this property, and that's if the consecutive angles will add up to 180 degrees. But by the consecutive ones, they got to be stacked on top of one another, not side to side. But speaking of base angles, if you know one pair of base angles is congruent, then you can conclude that you have an isosceles trapezoid. That's what this image is showcasing right there. This image is showcasing that in an isosceles trapezoid, the diagonals are congruent. So TR would be congruent to QS, but only if it's an isosceles trapezoid. If it's not an isosceles trapezoid, then the diagonals will not be congruent. So in this first example, I have this picture of a speaker, and the diagonals meet at point L right there. And I'm given that measure of FJH is 85 degrees, FL is 8, and JG is 19. So let me label those. Okay, so I went ahead and labeled what was given to me. FL is 8. It's kind of hard to read, sorry. JG is 19, and angle FJH is 85. So with that information, we're going to figure out what LH equals, and then we're also going to figure out what FGH equals. So I'm going to do LH first because that's the simplest one. I failed to mention earlier that this is an isosceles trapezoid here. So to figure out LH, you just need to know that the diagonals are congruent. So LH is simply just going to equal 19, the whole length of your diagonal, minus 8, the little piece of the diagonal. So 19 minus 8 is 11. So 19 minus 8 equals 11. And then now I'll figure out FGH. So if FJH is 85, then we can conclude that, let's see, how do I want to say it? JHG or GHJ is also 85 degrees. All right? And we know that the sum of the angles on quadrilateral are 360 degrees. So we have 85 and 85, so that's 85 times 2. So that's going to be 170 degrees, excuse me. And so if I'm doing 360 times 2 times 85 or 360 times 170, I'm going to get 190 for my total. Now 190 represents the sum of these two angles there. And we know that base angles are congruent in an isosceles trapezoid. So since I have two congruent angles, I'll just chop 190 in half, and then that will figure out angle FGH. And that'll get me 95 degrees. There is an alternative way of doing this problem. And I did mention that the consecutive angles, remember if they're stacked on top of one another, would equal 180. So the alternate way is, and it's actually kind of less work if you think about it, would just be to do 180 minus 85. And that would figure out this angle right here, and we know that base angles are congruent, which is going to be this angle there. So 180 minus 85 is 95 degrees. So that would make this one 95, that would make this one 95. The next thing to cover is the midsegment of a trapezoid. So the midsegment of a trapezoid is going to be a segment that's inside of the trapezoid, right? And it is bisecting each leg of the trapezoid. And so I'm going to give you this little formula, and this one applies specifically to this shape, but it says BE equals 1/2 of AF plus CD. And so, in other words, the midsegment's going to equal 1/2 of the sum of base 1 plus base 2. So in this example here, if I'm going to figure out the midsegment of MN, I'm just going to say MN equals 1/2 the sum of base 1 plus base 2, 12 plus 28. And that's just 1/2 times 40, which is 20. So what if I give you a problem where I give you the midsegment, but not one of the bases? So I'll set this up like any other midsegment problem, except I already know what it's going to equal. It's going to equal 15. I just don't know what one of the bases is, right? So I have 15 equal to 1/2 times base 1 of x plus base 2 of 18.2. So you got a couple options. You can distribute this 1/2 and then just solve for x. But what I like to do is, since this 1/2 is multiplying by these two terms, I can clear out this fraction. I actually think it saves some time by clearing out this fraction. And so to clear out any fraction, you can just flip it and multiply it to both sides. So I'm going to multiply 2 over 1 to both sides, and that'll clear out that fraction on the outside of the parentheses, just leaving behind x plus 18.2. And then 2 over 1 times 15 is just 15 times 2, so that's 30. And so now this is just a one-step problem. Minus 18.2 to the other side, and then the answer is just a difference. So that's going to be x equals 11.8. Then you could always check your work by plugging it back in if you wanted to. Do 1/2 times 11.8 plus 18.2. 11.8 plus 18.2 is 30. 1/2 of 30 equals 15. So yes, this does equal 15. And so that's how you know you did it correctly. So the next thing to go over is a kite. A kite looks like you would expect it to look, right? Because there are kites in this shape that you fly at the beach. So a kite will have two pairs of congruent sides, and then it will have one pair of opposite congruent angles. And so the angles that you know are going to be congruent are going to be wedged in between the two different sides. So like this side is different than that side. So the angle in here is going to be congruent to the angle that's opposite of it, because it's wedged in between this side and this side, the 1 and the 2 side. So if you look at angle S here, that's in between 1 angle 1, and then this is 2 angle 2. So these angles are not congruent to each other, okay? And so that's kind of how you determine which opposite angles are going to be congruent. Also in a kite, the diagonals are perpendicular to one another, so they will form right triangles. So that means you might have to do Pythagorean theorem or something to figure out one of the three lengths in the triangle. So in this example here, I'm trying to find GFJ, that's just angle F. You can see that these two are not the congruent angles. Obviously they're different, but like I said before, this is 1 dash and 2 dashes, so angle F is going to be congruent to angle H, so it couldn't hurt to mark that. And we know that this is a four-sided figure, so all the angles are going to add up to 360 degrees. So I'm going to say 360 minus 128 and 72, and that's going to equal 160 degrees. And so since F and H are congruent, just cut 160 in half. So I'll say the measure of angle F equals 160 over 2, which is 80 degrees. Because that'll make this 80, that'll make this 80, which add up to 160, plus this to 128 and 72. This adds up to 200. 200 plus 160 is 360. So in this example here, I'm not giving you opposite angles, so you have to use your judgment. Am I going to put a 73 down here by the Y, or am I going to put a 121 down here by the Z? And so look at where the 73 is. It's in between two single dashed sides, so it's in between two congruent sides. So therefore, I cannot put the 73 over here because that's in between two different pairs of congruent sides. So the 121 is in between the 1 and the 2 dash side. And so that means this one is 121 as well. So measure of angle Y is just going to equal 360 minus 73 and minus 2 times 121. And so I get measure of angle Y equals 45 degrees when I subtract all those out. So in this example, we're trying to find zy, so I'll put an x right there. And you just got to remember that the diagonals intersect at a right angle. So this forms a right triangle, 8 and 24. And then x is across from the hypotenuse, so that's gonna, x is across from the right angle, so that's gonna make it the hypotenuse. So we'll do the Pythagorean theorem, a squared plus b squared equals c squared, and the c side will be the hypotenuse side, which is zy. So a squared plus b squared would be 8 squared plus 24 squared. It doesn't matter which side's a or b. All that matters is which side is c, which is the side across from the right angle. So 8 squared is going to be 64, and 24 squared is 576. Add those together and you get 640. So to solve this, we need to square root both sides. And so if you're going to simplify the radical, you got to think what two numbers multiply to get 640, and one of those needs to have a perfect square or be square rootable. And so you want to think of the biggest numbers possible. And so for me, that's 64 and 10. And you can take the square root of 64, that's 8. But the square root of 10 is just some decimal, so that stays behind. So the answer is going to be x equals 8 square root 10. But if you were to round that out, I'm going to round it to the nearest thousands place. So we'll just need to type that into our calculator. I get approximately 25.298. So in my final example, we're going to find RP. I'm given that 10 is MN, so you can say 10 is NP. And so NR is 6. So I know these intersect at a right angle, so I'm going to put a little X there because I don't know what RP is. But the 10 is across from the right angle, making that the hypotenuse. So you can say 6 squared plus x squared or 8x squared plus 6 squared would equal 10 squared. And so 6 squared is 36, x squared stays the same obviously, 10 squared is 100, minus your 36 to the other side, and 100 minus 36 is going to be 64. And so we just got to square root both sides, and if you square root the 64, you get 8. And so I'll just say RP equals 8 for my final answer. Now I feel obligated to mention that this was a what we call a Pythagorean triple, where all three numbers were whole numbers. This is a 6, 8, 10 Pythagorean triple, but if you cut those all in half, that's a 3, 4, 5 Pythagorean triple. It's just scaled up by a factor of 2. So just something to be on the lookout for. If you never pick up on that, as long as you do the Pythagorean theorem correctly, then you got nothing to worry about. You'll get the answer right. But just thought I'd mention it. Other than that, thank you for watching this video. Hope this helped, and goodbye.